Okay, we're looking at the Reliant Eldico T102 transmitter. This is part of the Reliant Eldico S119 radio system. More familiar to most folks as Collins S-line clones. This is the transmitter. We previously looked at the power supply. So what I'm going to do is just go over the external features of this, the controls, the connections on the back, and we'll take a look inside. I don't pretend to know a huge amount about this radio, nor the Collins, but we'll look at how it goes. Most folks who aren't into vintage radios are familiar with transceivers, where the receiver and the transmitter, the VFO, are all in one box. They share a lot of common components. The VFO, the IF, power supply are all shared. This is part of the older scheme of things. Up until the late 50s, separate receiver and transmitter were the way things were done, and a lot of the early sideband stuff was done that way, with separate receivers and transmitters that really didn't interconnect much. They shared a TR relay, and that was about it. In this system, which is essentially the Collins system, the receiver and the transmitter can interconnect and share a VFO and share actually the upper and lower sideband oscillator, and can transceive together. Supposed to be on the same frequency. Practice, it doesn't always work out that way, but if you get them adjusted right, they do. Several other manufacturers after Collins went along that same path, making a separate receiver and transmitter that interconnected and could transceive together. Heathkit made the SB 300, 400 and the 301, 401. Drake made their T4 XRX4 separates that would transceive together. Yaesu made the FL 101, R101 separate receiver and transmitter that would transceive together. But almost all of those companies, in fact, all of those companies also made transceivers where they combined elements from those designs into a single box. So you got the Hot Water 101, the SB, Hot Water 100, Hot Water 101, SB 100, SB 101, FT 101 from Yaesu, and TR3, TR4 from Drake. So Collins did it with the KWM1, KWM2 series, but these Eldicos, later badged as Reliant, with Eldico as a division of Reliant, were made primarily as a government contract. During the wonderful days of fear of thermonuclear war, the government had an awful lot of Collins S-line equipment in embassies, Mars radio stations, military installations, and they wanted another company to second source, as they say, an interchangeable radio system, so that if the Ruskies that decided to blow Council Bluffs Collins plant off the face of the earth, there'd be another plant, in this case in New Jersey, making similar radios. And much to Collins' chagrin, the government let a contract to Eldico to make this S119 system, and this T102 is the transmitter part of that. And with a couple of minor exceptions, this is basically repackaged Collins S-line transmitter. I don't know enough about the Collins because I've only owned them once, and that didn't keep them to comment about the differences, so I'm not going to talk about Collins. We'll just talk about what we see in front of us. So basically what we've got here is a transmitter that operates on 3 to 30 megahertz in 200 kc bands. And down here you can see, and it will transmit with the appropriate band crystals anywhere in that 3 to 30 megahertz range. So it came with crystals for the ham bands. You can see it in 200 kc slices: 3.4, 3.6, 3.8, 7, 7.2, 14, 14.2, all the way around to the end of 10 meters. But in there you'll also see this 3C band, which allows you to basically stick in any darn crystal you want. And this switch here says amateur or special. And if you've got an out-of-band crystal to transmit on some other frequency, like a Mars frequency or something else, that's how you did it. So the controls are pretty straightforward. Up here you can choose between letting the transmitter control the VFO, and the transmitter control the transmit frequency, letting the receiver control it, or tie in the. If you put it in sync, that's basically a zero beating, so that you can hear the transmitter frequency in the receiver. So that just selects what VFO you're working. Exciter tuning is just what it says. Mod level is just audio gain control. There's your band switch. This is a Vox enabled radio, so you can turn the switch down here, make it click to push to talk, or disable the push to talk, and you got Vox. And what they are calling QT is the anti-Vox circuit to keep your receiver from tripping off the transmitter. Collins pattern for the dial, same here. Take whatever your band frequency is, say it's 3.8, and add the big number up here. So this is 3890 is about what we're on here. 80, 90, 38, 95, and here's the 1kc dial down here, so we're 38, 96, 38, 97. This little knob down at the bottom lets you calibrate this thing. So you turn on the crystal calibrator, zero beat it, set the little cursor, and then your calibration is going to be right on the nose. This is an anti-backlash dial, very little slop in it. We'll look inside and see how it works later. Plate tuning and plate loading. This transmitter has a roller inductor for the plate tank circuit, so this is a multi-tune knob. You're going to be tuning quite a bit, trying to find your resonant point, so you probably want to write it down, but they've got it marked here to give you an idea of where you are. And there's the plate loading. That adjusts your plate loading capacitor. Metering is typical. Plate current on the top line. You can also, I think, read be a way to read the grid drive. I'm not quite sure. I haven't used this transmitter very much. and what they're calling APL is what everybody else calls ALC. So that's all that is. Mode switch down here, lower sideband, upper sideband CW. Tune position just lowers the screen voltage on the finals to limit the plate current, and if you put it in the lock key, you just key in the transmitter. There's the meter switch, so plate current, grid current, and ALC. Again, we said that's anti-vox. So that's all the controls there are on this pig, and pretty straightforward. Let's take a look, go around to the back and look at the back skirt. Notable here, this has a Collins type mic jack. This is not a standard 1/4-inch jack. It's the smaller Collins style, and it's wired differently from everybody else in the universe. Almost everybody has the push-to-talk on the tip of the mic jack and the mic connection on the ring. This is backwards, so you don't want to plug an ordinary mic in there. You'll just burn the thing out. Nobody knows why they did that. I made an adapter, so because I use 1/4-inch mic jacks for everything here. The only thing I have that kind of mic jack on are carbon mics. But if you have a Collins mic that you want to plug in here, make yourself an adapter or get in the radio and rewire the plug so that it's conventional, whichever you choose to do. But don't just plug your mic in there or you're going to lose it. Well, in the rather famous tradition of YouTube videos, I'll sit here and explain things to you I don't understand. I think rather than doing that, I'm just going to say that it's been a couple of months since I had this on the air. They're new radios to me. I don't remember everything. I have to refer to the manual. If you get one of these things, get the manual and refer to it before you hook it up, because everything's not just as straightforward as you might think it would be. A little of the nomenclature is a little confusing. They've got provisions for muting the receiver. There's a bunch of cabling that goes between the receiver and the transmitter. One of the things is a mute line to mute the receiver when you transmit. Blocking bias is intended to provide bias to block a linear amplifier if you're running QSK. I can't remember why there's two key jacks. I'd have to look in the manual. Phone patch input is self-explanatory. QT is anti-vox. It's very confusing to me, but that's anti-vox, and you don't want to get that thing set wrong, or you can't key the transmitter. There has to be a shorting plug here in this jack. I don't even remember why, but there has to be, and I don't remember what J2B is. Have to look in the manual. Okay, bias adjust. This is the bias for the final amplifier tubes, the 6146s, so that they are running linear class AB1 or AB2, whichever one they run. Here's the RF output that goes to your antenna, and yeah, they're using an RCA jack, and you have to have the solder-on plug to plug into it. I've got a bunch of adapters that plug into an RCA jack and let me plug a PL259 in here, but they're so fat that you can't use them. So what you're going to have to do is get yourself some RG58 and solder RCA connectors on there so that you can use it. And so the antenna goes in here to a J1B, and then the antenna comes back out and goes to the receiver. So there you go. No converter being used here, so you don't have to worry about that. This transmitter has a separate power supply, another video on that, and it plugs in right there. So there's the rear panel. Now this hole here in the back of the case is important because you're going to pipe cables over from the receiver and plug them into the transmitter inside the radio to bring over the carrier oscillator and the VFO. So those wires, those cables go in there. Now if you're used to looking at S lines, this thing's going to look kind of odd to you, but it grows on you. And when you look at how they built this thing, realize it's really pretty nice. The chassis is cadmium plated. I think this is steel. Let's get my little magnet inside. I don't want to tell a lie. No, that's anodized aluminum. Okay, so the chassis is anodized aluminum, and the case I think is also aluminum. Feels like it. Magnet doesn't stick. So aluminum case, anodized aluminum chassis. It's pretty light. I think this whole thing weighs 17 pounds. Now those of you who are Collins guys, this will probably all look pretty familiar. Okay, this just a page out of the manual, which kind of shows you the physical layout of this transmitter, and you can go through here and look at its function by function pretty easily. This is the low-level audio here. Next to it is the balance modulator. Upper and lower sideband carrier oscillator. First and second balance mixer right here. So what you're doing is you're running the audio into the balance mixer, beats against the upper lower sideband oscillator in this mixer, RF into the other mixer, and then it goes through the filter and the driver. So here's the band crystals here, and the associated crystal oscillator tube. If you have auxiliary crystals, they would go in here. This is just the Vox business here, voice control anti-Vox, tone oscillator and keying tube, so Vox keying. And this whole business here is the RF driver section, and it's like the Collins. This thing is all on a geared plunger. There's the gearing, and that thing goes up and down, and tuning coils over here, all associated with their trimmers here, and the alignment procedure is in the manual. And all these things are pretty much labeled. Let's get some better light on here so we can read it. And a crystal oscillator plate, second mixer, RF amplifier plate, driver plate. So there you go. Here's the final amplifier cage, and in there you can see the roller inductor, and it's a progressively wound so that spacing will get a lot farther apart when you get up to 10 and 15 meters. Pair of 6146s. Loading control is pretty straightforward. So that's that. And here's the VFO LMO here. Again, it's a when you're tuning this, you're moving a coil, plunger inside a coil, to give you a linear minute. So when you're running this and letting the receiver control it, you've got a cable that comes in here, and the VFO from the receiver will plug in there. So you've got a switch, and this says transmitter VFO. You've got a switch on the panel, so you're switching between whether you're going to control the transmitter frequency with the receiver VFO or the transmitter VFO. And another one over here where you can use the crystal oscillator from the receiver or the transmitter. There's the Vox threshold. So it's that's the overview of it, and the frequency architecture is pretty simple. The combination of the VFO runs around 2.5 megacycles. The IF is, or the upper or lower sideband oscillator is another 0.5 megacycle. You put those together and you get about 3 megacycles, which is the IF. And then up to 20 meters, you add that 3 megacycles to your band edge frequency. On 80 meters, if it's 3.5 megacycles, and you add 3 to that, and so the 80 meter crystal is 6.5 megacycles, and it works like that up to 20 meters. And up to 20 meters, you add whatever the operating frequency is to 3 megacycles and divide it in half, and that's your band crystal frequency. So this is slightly different than the Collins. I think they're 100 kc different or something like that. But basically the architecture is the same, and the VFO is always running in around 2.5 megacycles. So the tubes in this Eldico are just as common as can be. The only one that's odd at all is this crystal oscillator, which is 6AH6, and it's not that odd. But everything else is just real familiar. 6U8, 6AL5. There's 4 12AT7s in this thing, and 12BY7 driver. More 12AT7s. There's 6 CD6 here. Another 6U8, and another 6U8. What are those other tubes in the transmitter? I can't. Here we go. Another 12AT7. They're using 12AT7s as the mixers in here. Common tube, not expensive, thank God. And that's a 12BY7, and 6146s in the final. So sorry for the camera waving, but that's the basic deal. I'll take it out of the cabinet in a minute, and we'll look inside. I want to look in and see what I got there, and give it a little cleaning. I thought it'd be interesting to look at the basic specifications of this thing. So here we got carrier suppression 50 dB down, sideband suppression 50 dB down, oscillator and mixer products 50 dB down, second harmonics 50 dB down, third order distortion 30 dB down. I hate to say it, but some of the earlier solid state synthesized radios did not do anywhere near this well. They had a whole lot of weird mixing products that were not well suppressed. So some of those early Kenwoods and stuff that used frequency synthesis were not the best things that ever came down the block. Okay, we're just going to go ahead and take this thing out of the cabinet. First time I've done this, so you can watch me make mistakes and laugh at me all you want. The power supply, oops, had the same kind of deal with rubber feet and a washer and I guess a number 8 screw. And you took the 4 It's got a different screw in it. You took the feet off and it lifted right out of the case, and this appears to not going to be any different. So in terms of getting it apart to service it, missing the washer there, pretty nice. These cabinets are nicely made, and I guess you can see that the whole bottom of it is perforated. So lots of ventilation, which is always a good thing. Alright, so now you will watch me do something for the first time I've never done. Good thing about this is that an aluminum radio and an old guy like me can lift it pretty easily. Now it appears that this thing should lift right out of here, and the question is, what can you grab? And I think there's something I don't understand. We'll have to find out what it is. Those screws in the back. It should come out of there. Yep, there it goes. Very interesting. What they say, when in doubt, force it, right? That's an odd way to attack it. There we go. This without doing it any grief. My God, I see a transistor. What the hell could that possibly be? Well, I got a pretty good idea that's not part of the original circuit. Well, let's just flop this guy over and make sure that we're not going to damage anything. Okay. We're all right. Put a little block of wood under there just in case. So now I gotta look in the viewfinder here and see what you can see, if anything. Well, we'll just go in here and take a look. See what we can see. I might put the camera in my hand in a minute. And I'll just tell you what I'm seeing. This is my first look inside this radio. Well, you know as much about it as I do. And what I'm seeing, a handy dandy little magnet pointer, I'm seeing a Sprague electrolytic capacitor in here, 16 microfarads at 350 volts. This looks like one of those good old beaver capacitors, my favorites. Another little electrolytic. Can't tell quite what it is. This is the audio section. That is mixers there. Balance mixer, first, second mixer, I think. No, those are the upper and lower sideband crystal oscillators. That's what that is. So anyway, there's a paper capacitor there. There's two little electrolytics. There's a plastic coated paper capacitor. Couple of relays, whole mess of ceramic capacitors. Here's another little, here's two more. I think that's a little electrolytic in there, and so is that one. Yeah, this is the audio section in here. I had it upside down. This is the audio section, so those are probably cathode bypass capacitors, three of them. Yeah, 50 working volts. So those are cathode bypass capacitors on audio stages. No big deal. I'm seeing paper coil forms, phenolic band switches, Collins filter in here, of course. So Allen Bradley parts, you know, good old American stuff, couple of relays. Everything looks clean and unmolested, as far as I can tell. Now over here, there's a little tiny circuit board with one transistor, one capacitor, one resistor on it, and I don't know what it is. I got a pretty good idea that it's not original, but it's appears to be in the audio circuit, and I can't tell you much more than that about it. Well, let's, I'm going to flip this up here, and hopefully you can see it a little better. Some light on it. I'll look in the viewfinder again. And yeah, get this thing out of the way, that'll help. Let me move this lamp out of the way. I got the wrong glasses on. Yeah, we'll just take a look here. So this is the what the hell we got here? Yeah. That's the audio section. This is three little paper electrolytics, low voltage electrolytics in there, and that's that little circuit board. I'm going to look at the schematic, but I doubt very much that that's original. Well, it could be. There's the band switch, and you can get a load of the construction and the kind of components that are in here. That's the bottom of the PA section right there. I believe. mixers. Get down here in this section, quite sure. Gotta look myself. Mode switch, meter switch, so let's see. This shaft down here, that's the mode switch. So it's going over there and selecting the upper lower sideband oscillator. Here's the push to talk relays and stuff, and the electrolytics that I was telling you about. No big deal, not much to do in there. All in all, pretty nice. Good wiring harness. I don't see any damaged components, nothing dirty, not a lot to do there. There's the paper capacitor, there's an electrolytic, there's a couple of electrolytics. So there's 1, 2, 3, 4, 5, 6, 7 little electrolytics in there that could be changed out, and that's about it, unless there's something wrong with it. I'll probably shoot the switches and the controls with deoxit while I'm in here and put it back together. I'm going to go and do a little homework and see if I can figure out what this little, that's a fairly old, it says, I guess that's a Motorola, so try to figure out what the heck that is. Well, I followed that white wire with the blue trace over, and it goes to the keying jack on the back apron, and then you can see that these where are these wires here go down to the keying tube. So this is some kind of a single transistor interface with the keying circuit. I'm not sure quite for what purpose, but you can see in there maybe that they've clipped the resistor. That resistor there has just been clipped and it's hanging, and so I think they may have bypassed a stage of the keying and done it a different way for whatever reason. I don't know, but that's all I can figure out. You can see this piece of white coax that's been added in here, and it goes from one of the spare RCA jacks on the back down here to this little terminal strip, and through this blocking capacitor to this little voltage divider, which goes to pin 6 of the carrier oscillator tube, which is connected to the upper sideband position on the mode switch. So, not quite sure what they're doing there, but it looks like they're picking off the 455 kc upper sideband oscillator signal and running it out to that jack. Now, why they wanted to do that, I don't know. But maybe for offset for a digital frequency counter or something. I don't know why, but it's there. And those are the only two obvious mods I can find in this thing.